Here we are going to discuss question number 65 of GATE 2022 Chemistry. The question is to find out change in entropy of the surroundings to convert 1 mole of supercooled water at 263 Kelvin to ice at 263 Kelvin at 1 bar pressure. And the additional information given are standard enthalpy of fusion at 273 Kelvin is 6 kilojoule mole inverse and molar heat capacity of water is higher than that of ice by 37 joule Kelvin inverse mole inverse. Let's look into the question. Water at 263 Kelvin should be converted to ice at 263 Kelvin and we need to find out delta S surroundings. The process here is an irreversible process and additional information given are delta HF at 273 Kelvin and Cp water is equal to Cp ice plus 37 joule Kelvin inverse mole inverse. To calculate delta S surroundings, we need to use an equation which is given as delta SF is equal to delta HF by TF, where delta HF is delta HF at 263 Kelvin. But we have been given a delta HF at 273 Kelvin. So we need to use one more equation which explains the temperature dependence of enthalpy, and it is given as delta H T2 is equal to delta H T1 plus integral T1 to T2 delta Cp dt. This integral term can be rewritten as delta Cp into T2 minus T1. And the delta H T2 is the change in enthalpy at temperature T2. Delta H T1 is the change in enthalpy at temperature T1. And delta Cp is equal to Cp final minus Cp initial. Here Cp final is Cp of ice and Cp initial is Cp of water. And from the relation given here, it is clear that delta Cp is equal to minus 37 joule Kelvin inverse mole inverse. So the data given in the question are delta H T2 is 6000 joule mole inverse, T2 is 273 Kelvin, T1 is 263 Kelvin, and delta Cp is minus 37 joule Kelvin inverse mole inverse. When we put these terms in equation 2, we get delta H T1 as 5630 joule mole inverse. And using this particular delta H T1, we can calculate change in entropy of the surroundings as delta SF is equal to 5630 by 263, which is 21.4 joule Kelvin inverse mole inverse. So the question was to calculate delta S surroundings. If the question is to calculate delta S system, then the whole scenario would be different, where the whole process should be taken as a composite process. And first conversion would be water at 263 Kelvin to water at 273 Kelvin, for which we need to calculate a delta S1. And the next is water at 273 to ice at 273, for which we need to calculate a delta S2. And the third is ice at 273 Kelvin to ice at 263 Kelvin, for which it is delta S3. And to calculate delta S1 and delta S3, we can use this particular equation where delta S equal to Cp ln Tf by Ti for the first conversion. Water at 263 to water at 273, Cp would be Cp water, and for delta S3, Cp would be Cp ice. Tf and Ti are final and initial temperature. For calculating delta S2, we can use this particular equation where delta S is equal to nR ln Pf by Pi, and the sum of delta S1, delta S2 and delta S3 would be the total change in entropy of the system. So our question was to calculate the change in entropy of the surroundings to convert 1 mole of supercooled water at 263 Kelvin to ice at 263 Kelvin, and the answer is 21.40 joule Kelvin inverse mole inverse. For further information, you can access NPTEL video where the lecture is given by Dr. Arjit Kumar De in second law part 2, and the link is given here. Thank you.